So we've always learned that integer is 4 bytes. And way back when we did negative, blah, 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 all the way up to positive, blah, blah, blah. And, you know, that was that range of numbers. And that's what we can store in here. And there's a way for it to be positive and negative and so forth. But my question was, how do we know for sure that a char was 2 bytes? Well, the ASCII chart had the numbers from 0 to 255 for a total of 256 numbers. 256 numbers equals 2 to the 2, 4, 8, 16, 32, 64, 128. It's 2 to the 8th power. And when I start thinking binary and groups of 4, that's going to equal 4 here and a 4 there is 2 bytes. That's the whole 2 bytes, the ASCII, it all ties together. And, you know, become a computer nerd and start learning those little ins and outs. Just like if I took this and said, holy cannoli, this is 2 to the 16th power. So 256 is 2 to the 16th power. I'm just off on a tangent. 2 to the 16th power equals, well, oh boy, Siri's not going to know this. Siri's not going to know this, is she? What is 2 to the 16th power? Right, I went 4, 8, 12, 16. She lied to me anyhow. There, 65536. 65536. And that's where I get this range of negative 32,767 up to 32,768. Because if I cut this number in half, I get that. But this is one less because it includes 0, and on and on and on and on. We store everything on the computer with zeros and ones. It has an, excuse me, electrical charge, or it doesn't. But here is the way that I store the number 1297. This is called raw data. And today we're going to take another look at files and working with files. And, you know, if you start to think about it, so much of what businesses do deals with files. And we're going to take a look at storing this raw data as the binary, making something called a binary file. So the first, you know, leading into what you had to do to start with the code listings for today. And yeah, you ever wonder what to do with jokers? Jokers make great bookmarks. Yeah, great bookmarks. Don't throw them away. As we were just taking a look at, yeah, here's that number 1297 written as binary. We just talked about it. It's all great. And we're going to take a look at how we can write data to a binary file. Now, why write it to a binary file? Well, there's a couple of reasons, a couple of advantages. One is it's more efficient, believe it or not. You ever start hearing about people getting these crazy errors where they're off by negative 0.0000001 because of this or that other thing? The other thing, working with binary files, there's less conversions, okay? You're going to store the data in a binary format. It's not like a text file where you can just open it up and look at it and edit it. It's going to store it kind of crazy. And depending on what you open it up with, you're going to get different interpretations of what's stored there. Like if you open up with Notepad, it'll look like one thing. If you look at it, open it up with JGrasp, it might look like a different thing, you know, because it might read it in groups and you might get smiley faces and all different types of things. But we're going to start out with, and from your code listings, you know, we have a lot of information about working with binary files. And again, starting to talk some of the talk, this goes back to, yeah, we had this conversation with polymorphism, okay? And I'm taking a look at this. In order to work with a binary file, we need to create an object of the class file output stream, and then a variable data output stream, create an object of that, and then work with the whole. We have a reference variable, to reference another class kind of deal. So don't want to get into it very deep, but again, the output file variable references an object from up above so that it can link to the myinfo.dat file. It's like a way of doing the connection. Okay, something that we talked about before. Now I want to get ready, and I would like to figure out some of the things I need to do. If I want to, and you did this in 1113, you created a file, and when you want to write it into a binary file, here's the methods that go along with the data output stream class. The one that's the unique one, you know, all of these are write boolean, write byte, write char, all the way down. And I see something that's missing, and that's where this write UTF comes in. And what that does is it allows me to write a string. Okay, so that's something that we tuck away. It's unique, you know, Unicode text format. You'll forget about that as quick as possible. But it's to note that, you know, okay, he usually puts tables in here that are good, just like his bulleted things. How does it work? Well, it's really similar to what we've done in the past, but it's going to make everything run a little faster. Here's the line that Japheth said he had a little problem with, and it may be Ray Mel's problem, that line 11 with the throws IO exception. I just have an integer array of numbers, and I'm going to go through and write them to my data file. My data file is number.dats. Always, always, always making sure we close it. So hopefully you ran that. I'd be willing to doubt if you did anything, if you ran it and went, oh, it compiled and there are no errors, you were done with it. Hopefully a couple of you at least tried to open the data file up with a text editor and looked at it. And you can confirm that what I was saying a little while ago, it looks a little goofy. You can tell some of what's going on, but not necessarily all of what's going on. So just as I needed to learn a few new things about writing to a file, I'm going to need to do the same with input. Fortunately, instead of file output stream and data output stream, the two classes I'm going to use are file input stream and data input stream. Same kind of deal going on here. I need to make that connection, link up the actual data file name with the name that I want to use in my program, which is input file. So what's really happening here? Well, remember, I have some of the other things going on. When I have these different classes, I can use methods from those classes. So they're still around. Almost an identical chart on the next page or from the previous page. Again, I'm reading by my data type. And when it comes to strings, you know, this is something that got read in or written kind of late because nobody really knew how to deal with strings early on. Does anybody know what they used instead of strings? Some of you loved this back in CPS 161.
C strings?
Yeah, C strings. And a C string, in other words, for those that didn't have 161, a C string is a character array.
Yeah.
Okay, and you worked with the character array, and lots of different interesting things went on with that. Boom, another example. You typed it in and it worked. I kind of liked that the author put in this one for you. Hey, let's put in a little try and catch. Just in case it doesn't read it in and print it so that it doesn't blow up. I catch it and just end the file and I'm done, kind of deal. Okay, so binary files, they exist, they're great, and you know, everything's all happy-go-lucky. You type those two code listings in, you're starting to think, you know what, I'm getting to be a pretty fast typer after all these programming courses. And that's a little bit why I got into programming. Because back when I graduated high school in 1980, you know, in ninth grade, in eighth grade, they're trying to put you on a career track. And you know, so in ninth grade, everybody gets typing class. And yes, believe it or not, I had a typewriter in my typing class that wasn't plugged in. And it was the push keys and the carriage return and all of that bull crap. But I know, boring story, hang in there. So what happened was, one, I was good at math, and I was actually pretty good at typing. So I started taking typing classes with all the secretaries. Well, I can type 70 plus words a minute, and I got the math and the logic behind it. My high school math teacher said, well, there's this thing coming out. It's really new. It's called computer science. Maybe you should think about going to college for computer science. And that's where we all are today. And by the way, that led me through Shippensburg. And yes, in my first programming course, I did use punch cards. We wrote each line of code was on a single punch card. And then you made a big stack, and then off you went to the compiler, and then you had to watch it compile on the mainframe. And then you had to, oh boy. You folks, yeah.
Is that like the radix work? Was that where it came from?
Yes. Yep. Back working with punch code. How many columns? I can do 130 words per minute. Shut up. No, you can't.
Yeah, how accurate are you though?
Yeah. So I had a student brag one time in class, and then we went and we got on one of these time typing things. You know, we just did the Google, and we got on and found one, and then we started racing in class, and all of a sudden they weren't as fast as they said they were. That might be a world record.
That's an interesting story, Professor, but not relevant here.
I know, but anyhow. So I have more stories, Dan. I do have more stories.
Oh, I like the stories. I like the stories.
Okay. Second part of 11 points. Well, I also, more interesting story. We moved up from punch cards because we could go over and sit in the computer lab, and we had a terminal, and then we'd pick up a telephone, and we would type in a certain number, and then when we hear a certain sound, we'd lay the telephone on a cradle, and then it would connect to the computer that way. And yeah, I'm sorry, boring stories. Yep, no more boring stories. Part 2 of section 11.3, dealing with random access files. So as you're starting to see, there are different types of files for different uses. And this one's kind of interesting. I like this one. I like random access files. Okay. A random access file is a little different. And I guess I really shouldn't come down here and underline this one line. And that line says something along the lines of cassette tape and a compact disc. Because with random access files, we're not a cassette tape where we start at the beginning and we just have to progress all the way through. It's a little bit like a compact disc where I can jump around a little bit. Well, back when I was in college, Darren, we would have social gatherings on Friday night. And my one buddy and I, we would get all of our favorite 45s, and we would create cassette tapes we could play during those social gatherings. And we used to have really fun social gatherings. We would play Scrabble, and yeah. So, you know, anyhow. So, yeah, it's what I just said. So what if I have a long file and I'm doing that whole sequential from way back when, where I have to start in the beginning and slowly go through. And some of you have seen so many things by this course. You know, in 162, we learned about binary files, where we were able to look at a binary array, and cut it in half and move around that way. Some of you took 162 and you built trees and you had data stored all different ways. Well, random access file is just another one of those. I can get the job done a little bit faster than before. All right, instead of working with 2 classes this time, I'm going to work with 1 class. That's a random access file class, and taking a look at what's going on now. When I'm dealing with this, I need to include, and I believe you saw this in some of your code listings, the file name and a mode. Okay, there's 2 choices for mode. One is R and one is RW. R is to kind of protect yourself because it's read only, and you won't screw up what's inside the file. Read write allows you to edit the file, read from the file, make changes from the file, create the file.
I have a quick question, Professor.
Yeah.
So for that random access, like I'm just kind of, because I was in 162 last semester, like as
Yep.
far as searching sequentially, would this kind of be like a hash table that they're using to go to any point that they need to as far as searching?
Yes, yes, you're absolutely right.
Okay, that makes sense.
I'm going to go, Darren likes my stories today. So I'm going to go back all the way to, we had 5¼ inch floppy drives, 5¼ inch. And they looked something like this. They were flat, they were black, round, inside was a disc. They were 5¼ inch. But one of the things they had was a notch cut out. That notch was cut out because that made it read write. But what came with the disc was a pack of these little silver stickers. And yeah, and we take those little silver stickers and we would put it over top of that so that we could read only. We could write protected is what it was. And then we got really smart because we knew you could work both sides of the disc. So we took a hole punch and we would cut out this side, because on the one side we would have DOS to boot up the computer. Then we'd flip the disk over and we would load up BASIC or Pascal. So we didn't need 2 disks, we only needed 1 disk. And then of course, there was the 3½ inch floppy disk. By the way, I can go back to 8 and I forget what the other one was. And I forgot about flipping the disk. So there was the 3½, and I don't know if you remember, but that had a little metal thing at the top that would slide over and slide back. It would slide over but it also had a little tab inside of here that you could push it left or right to write protect. These are good stories. I like them. Darren doesn't like them, but I like them. So anyhow, that's where this R and this RW comes from. Write protecting something, so you only read from it. And you've seen that a couple of different places in computer science so far. All right, here's an example. I'm going to call the class random access file. I'm calling a constructor. The constructor is bringing in 2 strings. Make sure this is a string. The first is the name of the data file. The second is my access. What's the mode I can use here? Is it read or read write? Bullets are pretty good, all of the things I just said. Code listing 1115, you were like, yeah, we typed this in. Got a little long, but you typed it in. This is good because we're going to use this one in a couple of minutes. We're going to modify it. We're going to have something else go in instead of those letters. And you came and you linked it up and you got ready and you did write chars and stored those characters into a data file. And that's what we're going to be doing in a little bit, but something other than the letters of the alphabet. Okay, but not yet. So I have something called a file pointer. And I need to keep saying file pointer because I'll say pointer, and then some of you are going back to C++ and go, I know what a pointer is. And you get all excited about pointers. And, if you took 162, you did your linked list with pointers everywhere. You had all kinds of pointers. But a file pointer, when I get ready to work with an array, my file pointer goes right to the beginning of the memory of where that array is stored. Now, when I say array sub 6, it let me jump around. It let me jump down 6 times whatever number of bytes was the data that's being stored. And I could move around that array a little bit. Well, the same idea is going to occur here. I'm going to have a file and I want to be able to move around that file. Okay, so it starts at byte 0, like we just mentioned a little bit ago. It'll go all the way out to -1. Everything in the world of computer science starts at 0, except Pascal. It actually started at 1, believe it or not. But this file pointer is going to hold the location of where I'm at. Some neat things that can be done with file pointer. The first one is I can hit this thing and use this thing called seek. And seek is going to let me move. And in this case, seek is going to take me to the 99th location. Okay, so I'm assuming that there's going to be more than 99. I'm going to be reading in bytes. So one of the things I have to be careful of is what am I reading in and how I'd like to jump around. Okay, we'll talk a little bit about that. And well, it's right here. So if I want to go, let's wait and talk about that in a second. Down here at the bottom. Okay. I'm opening a file. It's a data file. I want to read from it. Move the file pointer to byte 5, and I'm going to read in a character. Now, if my data file is hello space mom, I almost put a lowercase b with a slash through it to represent space because that's the good old days. If I took this block of code and I said, all right, random file.seek, go there and read in the character. What character would I be reading in? So this was a little bit of a test to see who read ahead or who is glancing to the next page and going, okay. So if I'm jumping a certain byte and I jump, oh, if I'm trying to read in characters, characters are stored in 2 byte increments. So one of the things I need to remember when I'm seeking is what is it I'm seeking? So here, again, documentation. I love you, documentation. Move the file pointer to byte 5, which is the 6th byte. 0 and 1 is H. 2 and 3 is E. 4 and 5 is L. So I move it right past that L, and I should get the second L if I was reading them in this way. So backing up to where we started today, I need to know that characters are stored as 2 bytes. Integers are stored in bytes of 4. This little block of code. I have char sizes 2, so that whenever I want to move to the 5th one, I know to move it times 2. It would move it 10 to get me up to this 10th and 11th location. So seek is awesome. It just lets me jump around all over the place so I can read things in if my mode is R, or I can read and write if my mode is RW. Okay, 11:16. You didn't type this one in, did you? The answer should be no, because this is reading random letters in. And in this example, you'll see I go back to that data file where I put everything in, and I'm going to come in and, okay, so I want to jump around. And again, I do char size, or they do char size, which is 2 times 5, 10, which will get me to the 6th character in the alphabet. A, B, C, D, E, F should get me to F. And the output for this is F. So it reads it in. I want to get to the 10th character. I want to get to back to the 3rd character. It's going to allow me to jump around. Not too shabby. Okay, so now I want you to go to D2L. Let me flip this back. There I am. I want to close this. I want to go to D2L, and I need to refresh. Go to Subway. I know, right? And oh boy, where am I at here? I'm going to come in here, and I'm going to share my screen. And some of you have already opened this as well. Okay, so today we talked about binary files and random access files. What I want you to do is Down below, I gave you a little program to write the letters, okay? So there's 3 programs that's going to be involved in this. The first program is number 1. Number 1 is you're going to go manipulate code listing 1115. So instead of writing the alphabet in, you're going to write in PLPRPN, blah, 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 blah. Boom. You run that done, you create yourself a data file, a random access data file. The second thing is a program where you're going to manipulate your data file. You're going to go through it one at a time, sequentially, and if it equals a P, you're going to write an E over top of it. If it's a Q, you're going to make it an A. If it's a Z, you're going to make it an O. So you're going to go through sequentially and do all that. The second part of this program, you're going to manipulate it by going to the 4th character and make it a V. You're going to go to the 16th and make it a W, the 21st and make it a D, the 26th and make it an R. When all of that's done and you close the file, you're now going to open this 3rd one I gave you that should read the file and display it. So number 1 you have done, it was a code listing. Number 3 I'm giving you, I don't know why, I'm making it too easy. Number 2 is a manipulating program. You get the message, call me to your breakout room.
Can I ask a question?
Yep.
Did the book tell us how to insert into like the middle of a file without deleting, or can we only replace?
So if I'm writing to a data file, whatever I write is going to go to wherever file pointer is pointing. And sequentially, it'll be at the next memory location. And after I write it, it moves to the next memory location. Okay. So in essence, if you think about it, yes, because wherever I write is going to replace whatever is in that memory location at that moment. Okay.
Professor,
Yep.
For step 1, are those characters or are those actually like strings or?
That's a bunch of characters. So just like you had the alphabet in that previous code listing, instead of A, B, C, D, E, if you want to make it a whole bunch of characters like this, that would be great. Does a string work? I don't know, but just hard code them in there.
Okay, so we can ignore the spaces and just individual characters.
No, put the spaces in. That's a character.
The whole thing is a character then, like PL, PR, PN?
No, each one of those is its own individual character.
Right, okay.
So P will be stored in bytes 0 and 1. L ends up being stored in bytes 2, et cetera, et cetera. But O will get stored, or space will get stored in its own.
Okay.
Okay. So I'm going to put you in breakout rooms. You have about half an hour to do this, unless Darren would like another